Welcome to the training. Thank you for joining us. I'm Mary Benson from the Ameren, Illinois Act on Energy program, and I'm here with Yolete Hebert, who is an energy advisor with the program, and Lars Braz, who's an energy engineer. And today they're going to explain the lighting calculator that is part of the new construction application. Quick, before I turn it over to Yolete, I'm going to cover a couple of housekeeping items. If you have any questions during the presentation, Lars is going to be asking for questions at the end of each tab, so if you could please type those into the chat feature. I've got a picture of that on the screen there so you can see what that looks like, and just type those in and hit send. And also wanted to let you know that this session is going to last about 30 minutes. So now I'm going to turn it over to Yolete.
Thanks, Mary. Good morning, everyone, and thank you for joining us this morning. Before Lars gets into the nitty-gritty of the lighting calculator and how it works, I just wanted to spend a few minutes giving you sort of a higher-level picture of the new construction application and the lighting calculator in particular. Some may already be familiar with our new construction energy efficiency program. To now, it's been handled through a custom application, but we are now in the process, that is, Ameren, Illinois Act on Energy is now in the process of designing and implementing a program specifically geared toward the requirements of construction. And the first piece of that is the introduction of a lighting application specific to new construction, which will use a lighting calculator in order to determine the incentive levels. Follow-on phases for the new construction program, including picking up things like HVAC and building controls and things like that. But for right now, we're limiting it just to lighting, so that if you have a new construction project, other measures that you're taking in energy efficiency would still be handled through the custom application, with the portion being handled through the new construction lighting application. We are using an approach that is used in a number of other states, and is we're basing the incentive calculations upon the requirements of ASHRAE 2010. ASHRAE 2010 has lighting power density requirements for different space types. The incentive calculations will be computed based on improvement over the requirements of that standard. 2010 is expected to be adopted by the Illinois legislature early in 2012. The features of the calculator: there's a fixture code generator that will help you determine the correct fixture code for the type of light you're using. There's provisions for both interior and exterior lighting, again, based on the requirements of ASHRAE 2010. And incentive levels are tiered, so the more energy efficient your lighting design and implementation is, higher the incentive level, and Lars will be more specific about that as he goes through the calculator. The calculator and an associated application can be found on the new construction page of the Act on Energy website, and we, Act on Energy, are available to support you if you have any questions as you're trying to fill out information required by the calculator and the application. And I believe we'll be following up with an email to whoever's on the line with some contact information for you about that. That's basically all I wanted to cover. Thank you again for your participation, and I am going to turn it over to Lars, who's going to, as I said, explain in detail the use of the lighting calculator. Lars?
Thank you. My name is Lars Braz. I'm an energy engineer with SAIC out of the Syracuse office. So is there anyone that cannot see the calculator right now? If so, please send Mary a chat. Otherwise, I'll get started. The first, as Yoli had mentioned, there was a series of tabs in this calculator, again available on the Act on Energy program website. The tab here consists of instructions. There's some pretty general instructions at the top. Down below, there's some more specific definitions and descriptions of various fields on the lighting calculator itself. I'm not going to spend a lot of time on the instructions right now, but we'll go back and forth a little bit to get to the actual lighting calculator page to define items as needed. The next tab over for the instructions is called Fixture Code Legend. Now, when defining in the calculator what fixtures you intend to put in the various spaces, this calculator relies on fixture codes. The page gives a general description of how these codes are generated. For example, as you can see in the upper left there, they have F as the leading, indicating fluorescent. The number is for the lamp length, 4 feet, number of lamps, etc. Codes are explained a little bit lower here. So instead of linear fluorescent, you'd have CF for compact fluorescent, H for halogen, etc. Found that this legend is not helpful. It can be confusing and a bit inconsistent. So what I did was we created this next tab called the Fixture Code Generator. So what this does is you can put some big description fixtures, and it will actually generate a code which you copy and put into the lighting calculator. Example here, at the top, fluorescent, to linear fluorescent. Let's 2 foot with lamps and just a standard T lamp, electric ballast, and this code has been generated for us. And that the system that you are trying to create does not have a fixture code represented in the wattage table. I'll try and create something here. Then you'll to use a cut sheet fixture. So what this is a separate section on the wattage table, which is the tab over. The table contains up above a list of all the codes with their shin, some ballast information, the number of lamps, fixture, number of watts per lamp, and then finally average value fixture wattage based on kind of field measurements and cut sheets. And that your fixture combination is not represented in the list. What you do is where it says edit, put a kind of description. So here we could say slamp, T lamps, and we could put lamps fixture 6, watts per lamp, say 17, and I just say 100. So now this cut sheet 1 would become the fixture code for this fixture, and I'll show you how to enter that on the next tab here. Also of note, if you have issues with using the legend or the generator on the table, you can scroll the whole list, or along the top here you can filter various categories. Let's say you're looking for a lamp fix, you can just select show me fixtures with 2 lamps in them. Let's say your fixture wattage as well, 28 watts. Only your list of 600 fixtures is a small handful. So that's another way to go about finding the appropriate fixture code. So undo that. Turn to our wattage cut sheet portion. So the next tab over is the actual lighting form itself. And this is where you can put first top some basic information such as the applicant name, the facility name, date, etc. Here we have lighting zone. Now this only applies to exterior lighting, but in the event that your application has exterior in it, this is new for ASHRAE 2010. The outer lighting zone 0 through 4. And so the only thing that's defined back on this instructions tab. So I'm going to click back over here. So right, you can see applicant block information, lighting zone, exterior, and then the definition. So lighting zone 0 is for undeveloped areas in national parks, state parks, etc. 1 is developed areas of national parks, state parks. Lighting zone 2 is things like neighborhood business districts, residential zoning, light industrial. Skipping down to lighting zone 4, this would be high-density commercial, metropolitan areas, and then lighting zone 3 is for all other areas. So for now, just pick lighting zone 3, and we'll go through we'll do both exterior and then interior example on the calculator. This line down here is asked for total building square foot just for the interior. This is pretty straightforward. Just enter the building square footage. Now you can see I got a warning here saying building area inconsistent. It actually compares what we've entered here, 50,000, against the sum of the areas that have been entered on the calculator. And if any areas are not accounted for, you'll get a difference in the building area. And so sure that everything is accounted for to get an accurate representation of improvement over building baseline. So to the project basic information. On the left here we have building address. Straightforward. Floor of the building, again, straightforward. Here we have area description. Now this one has to do with whether or not occupancy sensors are required by code on interior spaces. Let me zoom in there so you can see the list a little bit better. So spaces listed here, classrooms, conference rooms, etc. Sensors are required by code. In those cases, we can't claim energy savings based on occupancy sensors. If the space type is not presented by one of these, then simply select other, and then we'll know that occupancy sensors are not required, and in the event that they are installed, we'll go towards overall energy savings and therefore overall incentive. So next column over here, simply interior or exterior. Now I'll do an interior example, and I'll come to exterior later. Next column over here, predominant space type. So here it is, office, school, retail, restaurant, grocery. There's also one, which we'd use for exterior lighting. Other. Your type is not represented by one of these, and yet other, you would to contact a program representative for appropriate determination of the baseline power density. This will be handled on a one-by-one basis. So let's just assume office. So the next column here, exciting description. It's not going to apply for now. We'll get to that. So we have units, and you can see square feet, listed there. But the number of feet that I'm applying for office with another designation. So let the open offices within this particular building and represent maybe 8% of the footage. We're going to put in 40% of our 50,000 square feet. So then we have lighting power density, watts per unit. So 0.9 watts per square is our unit. The baseline lower allowance for an office in A. So then our pre-kilowatts per space, that's calculated simply by taking the lighting power allowance times the square footage. 66 kilowatts in the baseline. go into proposed installation. So we propose fixture quantity and propose fixture code. So let's say we want to get a 4-foot E8, 2 lamps per fixture. Go over to the fixture code generator. Fluorescent, we want 4 feet, 2 lamps, and let's say just for fun that we have some 28-watt lamps and a reduced output low ballast factor. The codes we simply copy back over here. And so for a quantity of those, let's see what would be something reasonable. So we have 5 of those fixtures. So over here we see proposed watt per fixture, which was pulled from the wattage table, 45. And the kilowatts per space is simply that 45 watts per fixture times 500 fixtures, so we get 22.5 watts for our proposed. Next, we have our occupancy sensors required by code. In this case, we selected other for air description, so they're not required. And say that in our that we have installed occupancy sensors, installed 125 of them, saying that we have 1 controlling every 4 fixtures. Next, come here, interior change and connect code that just takes your pre-kilowatts per space minus your post-kilowatts. Extra is 0, it doesn't apply here. And then we have coincidence factor for demand and energy, opposed controls factor. These are all determined based on the space type, in this case, office. So if you bring anything there, it's all automatically calculated, like demand savings. And the prescribed equivalent full hours, again, that just is determined based on your space type, office. And then finally, your savings are calculated. Exterior kilowatt savings, we have exterior, in this case is 0. And then for sensor savings as well. Only on the last column here, the proposed fixture cut number. Submitting your application, and you have what we said, 4 2-lamp 20-watt fixture with a reduced ballast factor. If you build that as a cut sheet with some sort of designation, so fixture type J or something, you could enter that, and that way when we're going through, we know what to look for. So questions for Terry? Yeah, I'm just going to keep going here. Let's do an interior example, and then we come to exterior. So let's say that in addition to the office space that we just described, we also have the general office space. Let's say we also have some conference rooms. So here I'm going to select meeting or training room. Here, space is interior. Space type is still office. Exterior lighting description still does not apply. And then let's submit up the remaining 10,000 square feet of our building. So now, this is an additional 9 watts of power for the baseline. We wanted to use our cut sheet fixture that we had created before. So what we do is simply find cut sheet 1 down at our list. Although you could just type in and it'll also work. Simple. Like that. And enter a quantity. Let's see, 50 of those. So here, our occupancy is required by code. Yes, we're going to comply with code and have occupancy in the space. Line above, savings are calculated automatically. But in this, you can see under annual hours saved sensors, the value is 0 because we can't claim savings when it's required by code. Let's say that in addition to those spaces, those fixtures, the linear fluorescents, if we also wanted to add compact fluorescent downlights or some other type of, what we do is, and same thing again, but this is still for the conference room. We're going to leave the square foot here blank. We'll count that, and over here and enter our proposed fixture code and quantity. So to the generator, and we can just hit this one. We have a compact fluorescent, 11 watts, 1 lamp. So we can copy, paste, and say we have 10 of those mixed in. And occupancy sensors. Assume that they're controlled by the same 10 we mentioned above. Now here the interior change in connected load shows up as negative, but when you combine with the line above, the overall savings are still positive, so it's okay to tell you there. Likewise for the kilowatt hour savings. So let's do an exterior example. I get questions, just feel free to send a message to Mary and she'll forward it to me and I can try and answer. So description for exterior, it's going to be other to interior spaces. So here I'm going to select exterior. For that space type, I'm going to select down here dusk to dawn lighting. And here to the exterior lighting description. Since I haven't selected it, there's an error message displaying here saying please select the exterior description. So let me zoom in again so you can see this list a little bit better. These include general things like parking, walkways, stairways, entries, and then some specific things like out sales or entrances and inspection stations at guarded facilities, ATMs, drive-through windows, etc. So if we go with parking, I have 50,000 square feet of parking that we're adding this as part of this construction. Again, the units are still square feet. Other options, actually let me point that out. Other options could linear feet, let's say for walkways. So the units you'd put in the linear feet of walkway you have, or let's see what else we have. I think ATMs, it's you get per ATM, so the unit, the number of ATMs that you have. I think drive-through windows, the number of windows. Stick with part 50,000 square feet. Power density here. Say that we're using some LED pole lighting, which isn't in the wattage table. And we'll go ahead for another cut sheet fixture. And let's say it's 125 watts. Here, enter cut sheet 2. Let's say that we have 20 of those. Going on here, our occupancy sensors required no. Here you can see the saving up in the exterior change in connect load. at 2.5 kilowatts. Again, coincidence factor, all this stuff is automatically calculated behind the scenes. So the hours of use, and then finally we can see annual exterior fixture kilowatt hours saved. When everything is entered on the calculator and you've reconciled the square footage to match the total building square footage, the tab over is the project estimated summary page. So summary broken down by interior and exterior lighting, and this actually matches line what you need to enter on your application submitted along with your calculator. So going through interior light first, we have the kilowatt hour savings, followed by change in connected load in kilowatts, the cost savings, operating hours. Next one is aggregate lighting power density in watts per square foot. And it's the baseline, and this percent improvement is calculated based on those. On the percent improvement over baseline lighting power density, you get assigned to one of three tiers. So if we have tier 3, which is the highest tier, that's anything over 35%. And incentive is 12 cents per kilowatt hour. Tier 2 is anything between 25% and 35%, 10 cents per kilowatt hour. Tier 1 is anything between 15% and 25%, and for cents per kilowatt hour. And cent is the minimum percent improvement needed to receive incentives. Here is automatically generated, as is the incentive at the correct rate, 8,060 incentive. We have exterior lighting. So the estimated annual power savings, and the incentive for exterior is just a flat rate at cents per kilowatt hour. And the total, just takes the sum of those two, is capped at $100,000. Seen any questions come through from Mary? If they please for a chat. If not, reach the end of the presentation here. You'll leave.
Do you have any questions? You did a great job of explaining it.
Great. In that case, I will turn things back over to Yoli, who has a couple things to say.
Flars. Yeah, I just want to reiterate that if there are any follow-on questions, we are available to help you with going calculator and even filling it if you need that kind of support. You're seeing an email from us very shortly with contact information. And thank you very much for your interest, and we look forward to helping you work on your new construction applications. To wrap it up.
Sure. This concludes today's webinar. Thank you all very much for joining us, and have a great day.
Thank you.